In the final section here, while we're discussing network latency, I'm really going to talk just briefly about creating a network baseline. And this is something I've alluded to throughout the course, and especially in this section, but I felt it deserved its own section just to really drill it in and talk about a few best practices. So we'll just spend a few minutes on this topic. Now, as I mentioned for network baselines, really it's all about the concept that if you want to be able to identify abnormal, you must have a sense of what normal is. Otherwise, everything looks abnormal. And that's okay if you're just getting into this, if you're maybe a junior analyst and you don't have a lot of experience under your belt, or if you've never created a baseline before. But once you've had time with the network, you've built up your skills, you really know what you're doing, you still need to be able to spot abnormal. And if you don't know what normal is, this will plague you basically until the end of time. So understanding abnormal, very important, understanding normal, very important to understanding what is abnormal. And that's really the paramount reason why you would want to create a network baseline. Now, I'll talk in a couple minutes about things you want to include in that baseline, but I do want to talk about first some specific concerns with this when you're dealing with this type of work or this type of data. And those really relate to storage and search of the data you collect. Obviously, when you go to the trouble of finding your network baseline data, collecting packet captures, taking notes, things of that nature, you want to store those because you don't want to have to redo that every time, right? You want to put those in a centralized location. A lot of people think about that. The part people don't often think about is searching. You want to be able to search that information and get through it pretty quickly. If you just dump a whole bunch of capture files into a directory, sure, that's going to work, but it's going to really slow you down when it comes time to search it. In many cases, it might just be faster to go out and retrieve the data again. So you really want to make sure whatever you store it in is also easily searchable. Now, that said, I have a couple recommendations that I think make this easy if you just want to get started and you want to get started for free or cheap. If you already have a tool that can do this, great, use it. If you don't, here are a couple recommendations. First of all, you can start as simple as a wiki. There are a lot of wiki softwares out there. MediaWiki is a popular one. DokuWiki is one I use just because it's really easy to set up and really easy to use, and it has a very small footprint. That was DokuWiki. But with a wiki, you can create pages that contain notes. You can create a page for each network baseline category I'm going to talk about here in a minute. And you can also upload packet captures and things like that to that area. And it's very easily accessible via web interface to not only you, but other people in your enterprise, which is certainly something we want to do as well, play nice with others. Another option might be something a little bit more advanced is the combination of Elasticsearch, Logstash, and Kibana, or the ELK stack as it's more often called. So you have the ability to store arbitrary data into an Elasticsearch backend, access that via Kibana, which provides a really nice web-based interface for interacting with that data and searching through it. ELK may not be my first choice with this type of data. I might start with a wiki, but if you want to get a little crazy with it, maybe build some custom dashboards, do some advanced data analysis, maybe some aggregations or things like that with the data you're collecting, ELK stack might be the way to go there. Finally, consider creating a capture library. You can do this by just storing these in very well-named files. I want to make sure you do name those well and that they're easy to find and reference. But there are also pieces of software that will do this for you. Moloch is one of those. I believe that's an AOL-created tool that's still out there. I did say AOL. Moloch is a tool you can use. Another one I like is CloudShark. CloudShark is not free. It is a paid product, but it's pretty affordable for most enterprises, and it provides a really nice user interface for storing capture files, tagging them so they're easily searchable, and then searching through them en masse. And it even has some nice built-in analysis features similar to that of Wireshark. So CloudShark's a paid product, but it is one I am pretty fond of using. So that said, we're going to talk about categories and things you can collect in your baseline next, but you have to make sure you have a place to store this stuff and an easy way to search it. You can set up a wiki in really as little as 10 minutes after you've downloaded it, so no excuse not to do that, even if it's just a virtual machine or something like that existing on your laptop or on your local machine. So once you've found a place to store your baseline information and a way to search it, you're ready to go out and collect that information. And fortunately, we've already talked about a lot of those great techniques here and in this course, right? We talked about all these different ways you can tap into the wire. And to this point, you should be able, if you've mastered everything we've talked about, to be able to get the information you need. So the next important question is, what do you need? And I'm going to go through just a few of those things pretty quickly, just a few different things that I've seen that most organizations can benefit from collecting to some degree. Now, that's not me saying you need to or have to collect all of these things. Certainly, that may be a little bit time consuming, but these are areas where I've seen where having baseline information can be incredibly helpful for your analysis process. Now, I'm going to talk about these things, and they're really the degree to which you collect them is a little bit variable. In some cases, you may want to collect those for an entire site or an entire office. You may want to collect them for a specific host, maybe a sensitive or a critical host, maybe a domain controller, a web server, something of that nature, or maybe even a specific application, maybe your CRM application or your financial database, something mission critical. That's really up to you how much of this data you collect. But these are just a few places to start. First, very simple. What protocols are in use on your network? I can guarantee your network probably has IP and TCP and UDP and all of those lower layer protocols we talked about. But specifically, what application layer protocols are in use in your network? That's a very interesting thing, and I think it's something everyone should be aware of. You should be able to look at a protocol hierarchy from Wireshark and not see anything you don't expect. If you do see something you don't expect, you want to investigate that. So you're going to see things like DNS or HTTP or maybe DHCP, but it's the things that you're not expecting that you want to look for. I said you'll see DHCP. Maybe you won't. Maybe you have a network where everything is using static IP addresses, and you don't expect to see DHCP, but then all of a sudden you do. So you find a host that maybe is running an illegal DHCP server. Maybe you have a host that's not getting an IP address, that's seeking an IP address, that's misconfigured. A lot of options here. So you want to understand what protocols are in use on your network so you can spot the ones that are anomalous. Next, you want to look for broadcast traffic. And this is a pretty broad category. Of course, most networks are going to have ARP on them, so you're going to see ARP broadcasting. But if you have anything else sending broadcast traffic, you want to see this because you want to see this and you want to capture it. And you want to understand what's going on because broadcast traffic is, to a large degree, very inefficient. And chances are it may be nothing malicious, maybe nothing out of the ordinary, but get a sense of where your broadcast traffic is coming from and what the deal with it is. Next is authentication sequences. And authentication is an important thing we do to really multiple things in our network. We authenticate to our workstations. We authenticate to internal applications. We do a lot of authenticating. So understanding that process and how it works will really be helpful when it fails, particularly when it fails because maybe a server is rejecting an authentication but providing a not too helpful message back to the user, or even when it's just really slow. Maybe it's even failing because of high latency. So you can see how long authentication sequences typically take, and if you capture one later on that takes 3 or 4 times longer, you'll know that that's actually the case, that it's actually supposed to be much faster than that. Next is data transfer rate, and this goes back to a lot of our discussion of latency, but knowing how fast the normal transfer is between 2 hosts on your network that are critical is going to be important to identifying when something is truly out of whack. If you're having trouble with a file copy from one place to another and you suspect it's latency based, well, you can actually go back to your baseline, look at that capture you've previously gotten where you know things were working perfectly, and if it's the same data transfer rate, you know that maybe there's probably another problem. A lot of the things we're getting for baseline data are for the reason that applications often don't give us enough information that we need to solve issues. So data transfer rate and knowing that and being able to rule that out as an issue is a good route to go in this case. Next is idle or busy traffic, and this is really useful for your sensitive host, I think. I do this a lot on domain controllers, application servers, things of that nature. And what that means is just getting a sample of what that server looks like when it's busy and when it's idle. So busy would be obviously maybe in the middle of the day, 2 p.m. during a busy work day. Idle would be middle of the night, 2 a.m. in the middle of the night when nobody's working. By understanding what the server traffic looks like when it's busy or idle, you have a better baseline to diagnose potential issues that come up at either of those times. Really useful for diagnosing maybe late night backup issues, maybe diagnosing weird server spikes of activity in the middle of the night, seeing if those types of things are normal. So idle, busy traffic for a particular application, host, or maybe even an entire site. Also useful for diagnosing security issues when you maybe have something installed on a machine that's downloading or uploading data late at night or at a time that might otherwise not be expected. Startup and shutdown is another example where systems can be really busy, very chatty. So by looking at a system when it's starting up, you can see initial connections established out to third-party services, and that can be a really useful thing to know, especially if you have a device later on that is starting up slow. And I've seen this a lot, is people will install some type of application that updates on startup, and whatever server they try to update to maybe goes down, and the startup process is to some degree contingent upon that, and it slows the system down during startup. So you have a user complaining that it's taking 5 minutes for their machine to start up, and it normally just takes 1. So you can identify these issues this way by creating a normal baseline of what a startup of a machine on your network looks like, and then comparing other things to it. In this case, you probably don't want to create one of every machine in your network, but you want to take your gold image or your standard deployable system image, capture the startup process of that from the network perspective, and that gives you a baseline to work with when you're looking at other systems down the road. Finally, associations and dependencies. This means keeping track of what systems normally talk to other systems and what systems are dependent upon other systems as well. For instance, we often have web servers that are backed by database servers. So being able to know and track the dependencies of those web servers to those database servers is very useful when it comes troubleshooting time. That way, if someone says I have an issue with the web server, you can very quickly look and say, okay, this web server talks to this database server where it gets its data. The user is experiencing a problem, and it could be the web server, but it could all very well as well be the database server. So by knowing that this dependency and this association exists, you're able to more quickly identify the areas you might need to troubleshoot so you can locate the source of the problem. So that's it for this particular section and this module in general on creating a network baseline and also troubleshooting high latency or drop packets or things of that nature. So I hope this section was useful to you. I know this last one was a little bit of me just rambling about creating network baselines, but it was really meant to be just kind of a list of best practices, things I've seen that are helpful to people. One of the questions I most often get asked after I teach packet analysis is, man, I'm really dying to get lost in some packets. What can I do next? And I really tell people, start by creating a network baseline. It gives you a lot of practice doing the things we've talked about here, doing and using the different analytic techniques. And it also helps you learn a lot more about your network. So by creating a network baseline, you really can test and really practice the skills that you're learning in this course. So if you're looking for something to do immediately to get your hands or your feet wet in packet analysis, start creating a network baseline, take some of the recommendations I made here, start getting those packets and trying to make sense of them.